Hi, my name is Xenia, and this is how to generate database models with the Data Map Creator. The Data Map Creator is part of the TIL Toolkit, a library which can be loaded in Daimler. After it has been loaded, it appears in the toolbar over here. And here you can select what kind of database fluid flow machine you want to generate. Today we want to generate a VLE fluid compressor, a compressor for real fluids. Next, the data map creator opens in your browser locally. As you can see here, creating a database fluid flow machine is divided into several steps. The first being component selection. Here you can choose what TIL version your component should be in. The quantities that are listed over here are the ones that need to be in your dataset, and here you can choose what component is it that you want to create. As already mentioned, in the next step, you can open your dataset. To get a better understanding of what your dataset should look like, you can open an example dataset first. The adjustments which can be made to it are listed on the left-hand side. For example, you can exclude certain rows with these two features, and here with this option, you can even shorten your dataset. But that's not what we're gonna do today, so let's carry on. In the following step, we map our quantities of the dataset to the variables that are listed over here. In this case, we select the column of the data, the column that contains the mass flow weighted data. And the diagram in the center gives an instant feedback on your selection over here, as you can see. It portrays the raw data points of your dataset. What you also need to do is to type in the factor that is needed to convert your data into SI units. The effect the factor has on your dataset is portrayed in the table on the right-hand side, as you can see. Apart from this, you also need to enter your the values of the pressure and the temperature at which your data has been measured. The following step is all about the processing of the isoline variable. The isoline variable is the one that is kept constant while different measuring points are being recorded. In our case, it is the rotational speed. So let's carry on. The data map creator calculates the mean value of each isoline, and if your isoline variable contains outliers that you want to omit, you can activate this option and type in the accepted range. Here you can decide how you want to approximate along each isoline. These diagrams over here, they give you a preview of what your data map is going to look like. And if you select curve fitting, you have the possibility to extrapolate as well. In this case, your data map is going to be extended by 30% of the total length of each isoline to the right. When it comes to interpolating and fitting between isolines, you have the same options available. Okay, so let's carry on. In this step, you can see how well the fit worked. For each created data map, there is a diagram shown here. Graphically speaking, the more dots that are on this diagonal, the better the fit. And you can also see how well the fit worked according to these values over here. The R squared value, for instance, the closer it is to 1, the better the approximation. And these other three tabs, there are the created data maps shown in 2D as well as in 3D over here. What you also can see here is that we have been extrapolating along isolines to the right. These red lines are the approximating functions that have been determined in step 4 along isolines. And on top of that, here are the approximating functions added that have been determined in step 4 between isolines. The resulting data map can be seen in this diagram. And in case you are not happy with your results, you can always go back to step 4 and make different adjustments. However, if you want to carry on, you can download your database fluid flow machine over here and follow these instructions. After you have loaded your created package in Daimler, it looks like this. The package consists of these models, the created database fluid flow machine itself, the created data maps, and the data map visualizers, which I'll explain in a second. Today we're going to have a look at this tester. The medium you used, you need to select here, and after simulation you get a better understanding of what these data map visualizers do. They portray the current operating point in each data map. All you need to do is to include these data maps, these data map visualizers in your model, and adapt these to quantities in the text view. Which brings us to the end of the tutorial. If you have any questions, please let us know in the comments down below, and please subscribe so we do not get lost in your algorithm. Thank you. Goodbye.